All right, you should have your packet. You should also have your planner, okay? Packet and your planner. Let's write our first and last name. Today is the 13th. The assignments due this week, we have our warm up, we have our homework. Please mark out the word quiz. We have our cluster test this week, our cluster 4 test. Okay, please make sure that you study. You need to study equations, linear equations, writing them, graphing them, comparing them. Fourth period. Writing, graphing. There's not a lot of graphing on this one, I don't think, but it's still in this unit. Comparing. Okay, that's what the quiz is on. And then reading graphs, which that's what we're going over tomorrow. This is what your quiz is on this week. So please go back and look at your notes on linear equations. Let me pause for the calls. Yes, baby? You have a question? Graphing. Okay, so the essential questions are as follows. They're also on the board. Describe how to compare two functions. We're working on that today. As we describe making those comparisons, we're describing the rates of change, okay, and we're also describing the y-intercept. We don't really go into this just yet. It's a part of the question that they give us, but we don't go that in depth just yet, okay? We describe key features of a graph. That's what we're doing. We're going to work on that tomorrow. And then we're going to do systems of equations either Wednesday or Thursday, okay? And what does it mean to solve a system, which we've already started doing. Our agenda is on the side board. We're going to write in our planner. You get 10 points added to your assessment at the end of the week for having your planner filled out, okay? So make sure that you write daily what your homework is. We're going to complete the warm-up. We're going to do the warm-up together. Okay, then I'm going to go over, I'm going to model comparing functions, and then we'll probably work at our tables on some guided practice problems. Okay? Do not forget to study. Let's write our homework down in our planner. In our planner, we need to put that we're watching the homework help video. We're doing equations today, so please watch the homework help video on solving equations. Don't forget to also complete the problems. Complete the problems. I'm going to pause for the calls, give us a chance to write in our planner. All right, let's look at the warm-up. Anybody still writing in our planner? Okay, let me pause real quickly again and then turn to your warm-up. All right, good folks, we're going to look at the warm-up. In the warm-up, you're given a table and you're asked to find the rate of change and the starting amount and then write the equation. We're going to do this one together, and tomorrow I want you to try that one on your own. So remember to find the rate, which also means to find the slope. The letter for slope is M. The formula for slope when you're given ordered pairs is y2 minus y1 over x2 minus x1. Please write this down. What you need, Terrence? What's wrong, baby? Go get a pencil from up here, please, in a little pouch. All right, here we go. We're going to pick 2 points from the table. What 2 points would you like to choose? What 2 points do you feel like is going to be the easiest to substitute? 0, 3, and 1, 7. Okay. X1, Y1, X2, Y2. Label the ordered pairs. When we label those ordered pairs, what are we going to put on the top? What minus what? Yes, Tegan? 7 minus 3. 7 minus 3. And then say again, baby. 1 minus 0. Very good. 1 minus 0. Good job. So on the top, let's simplify. You have your calculator. If you don't remember, what is 7 minus 3? 4. And what is on the bottom? 1. So what's the slope equal to? What's 4 divided by 1? So m, or the slope, or the rate, is 4. Your rate here is 4. It's going up by 4 every time. So now you got to find your starting value. Your starting value is the same as the y-intercept. So your starting amount or value is the y-intercept, or b, okay? So to figure out what your y-intercept is, you look for where x is equal to 0. Whatever that y is, that's your y-intercept. So look at the table. Is there a place where x is equal to 0? Yes, where is it? This right here. X here is equal to 0. So this number right here is your y-intercept. B is equal to 3. B is equal to 3. All right, so now, how do I now write an equation in slope-intercept form, which is y equals mx plus b? If I have an m and a b, what do I write for the equation? Yes, baby?
Y equals 4x,
Mm-hmm.
and then plus 3.
Plus 3. Good job. This is your equation. I'm going to pause for the calls, okay? Put the packet in your folder, please. Yes, baby?
Is Miss Farrell?
I don't know. Make sure you put this sheet in front of you. Today is the 13th. 3. Sorry. Why do I keep putting 3? 2, 13, 23. Pause for the calls. All right, good folks. Okay, we're going to fold this paper in half so that we can write on the back side of it. This is the side we're not going to paste. And we're going to do just quick hand, short notes there. And then we're going to be comparing. And then I have a partner or group activity or sheet that I want us to do within our group, okay? So we're going to do this part first. I'm going to describe how to do it. I'm going to do a couple examples, and then I'm going to let you work with your partner or group, okay? This is going to be page 8. So at the top, we're going to write page 8. Don't write so big so that you'll have enough space. The name of this page is Comparing Functions. And we're going to put comparing linear functions. These all are situations that have constant rates of change. They graph straight lines. So we're going to say linear. Come on, Terrence, write this down, baby. Please don't write so big so that you'll have space to put everything on there. If you need a pencil, there's a pencil on the wall. Please choose your desk number. And if you use it, please put it back. Use it, please put it back. All right, here we go. We are going to be comparing functions. The first thing that we're going to learn how to do is compare slopes. So let's put compare slopes first, okay? We're going to compare slopes. The letter for slope is M. Another word is rate or rate of change. So we're going to compare slopes or rates of change. All right, so in comparing slopes or rates of change, that is when you compare, you are going to ignore the negative signs. So we're going to put an asterisk here, and we're going to write when comparing, or when compare which is smaller, when compare which is smaller or larger or greater. We're going to use the word larger for right now. Ignore the negative sign, comma, ignore negative sign. We're going to do some examples so that you can see what I'm talking about. Pause for the cause. I'm going to do some examples. All right. Example. I'm going to do one example with you, and then I'm going to see if you can do the other on your own. Okay. So let's do this one together. Examples, plural. Which slope is greater? Which slope is greater? Not smaller, but greater. Okay. Just the same as larger. First example, number one. If m, or the slope in one of the functions, is a -5 and m in the other function is a +3. We're going to write what this means first. This means, the first one means that whatever that function is going down by 5. So I'm going to put in layman terms, very simple language, that this means that it's going down by 5. This means, since it's a positive number, this means that this function is going up by 3, since it's a +3. The one that is going faster, no matter what direction it's in, is the one that's going down by 5. That's the larger slope. Even though it's going down by 5, it's still going faster than the other that is going up by 3. So I'm ignoring the negative. Okay, this is 5 if I ignore the negative. This is 3 if I ignore the negative. Okay, it's already positive. This is just saying that it's going down 5 and this is going up 3. This is still going faster. This is going at a faster rate, even though one is going up and the other is going down. So this one is going to be faster. This has the greater slope. Any questions so far? Let's see if you can do number 2. Which one of these have the greater slope? Circle the answer you think it is. Write what the meaning is, just as I've done here, and then circle the correct answer. So the first function has a slope of 7, and the second function has a slope of negative 12. I'm going to pause to see what we come up with, okay? You snuck an orange to him under the table. Maybe it's his orange. I don't know. But you look guilty because you're always asking for these oranges and then y'all make mess. I don't want to see these peelings and all this stuff that's on the floor, okay? So make sure that if you're going to eat it, clean up your mess. That's it. That's all I'm asking. That's it. All right. So this one, the meaning of this one is that we're going up by 7, okay? The meaning of this one is that we're going down by 12. The one that's going the fastest is the one that's going down by 12, even though it's represented by a negative number. It is going faster. This is the greater rate of change. This one is the greater slope.
Can you move the paper down just a little bit?
I think that you mean this way?
Yeah.
Oh, okay. Okay, we're gonna do comparing slopes. All right, I'll go back to it if you need it, Tegan. Okay, we're gonna compare the y-intercept now. Okay, so this time we're comparing the y-intercept, or the starting amount. The letter for y-intercept is B, or the starting amount. I'm gonna pause for the calls there. Who's after Frank? Okay. Was you after Frank? Who was after? No, that wasn't you, was it? Okay. All right. All right. Let's look and see. So here, guys, you cannot ignore the negatives. So this time, don't ignore the negatives when you are comparing from least to greatest. Don't ignore that negative. Unlike the slope, you ignore the negative. But when you're comparing the y-intercept, do not ignore negative signs. Okay, I'm going to pause for the calls, give us a chance to write. All right, good folks. Let's do an example. Or examples, plural. All right, so the first example, we are going to which y-intercept is the greatest? Which y-intercept is greater? Okay, so let's do this one. If the y-intercept for the first function is a negative 1/2, and the y-intercept for the second function is a positive 1/2, which one of these y-intercepts or starting amounts is going to be greater? You circle the one you think is greater. I'm going to pause for the calls, okay? Okay, so the one that's going to be greater, and 10 of us got this right, is going to be the positive 1/2. Positive numbers are bigger than negative numbers. Don't ignore the negatives. The only time you ignore the negatives is when you're comparing the slopes. But when we're talking about anything else, please take in consideration which one is smaller by looking at the negative and the positive, okay? This is the one that is greater. Any questions? Yes, baby. One more. Go ahead.
If there were like a -7 and a +2, would the +2 be greater?
Yes. Okay. So let's look at this one. Your y-intercept is 5 for the first function, and the y-intercept is -8 for the second function. Which one of those has the greater rate, the greater y-intercept, the greater starting amount? Excellent job. You're right. The starting amount that's greater is the +5. Okay. This is the one that is greater. If it asks for the smaller one, then of course you're going to choose the -8, but it's asking for the greater one. All right, so now let's open this up so we can do some examples together. All right, so now we're comparing functions. We're going to start with comparing the slopes. All right, so let's look at these two right here. We're going to circle the one that is greater, and then we're going to explain how and why it's greater out here. So let's look at this scenario. A car begins a road trip, begins at 52 miles from home, okay? And travels at a rate of 60 miles per hour. Which one of those numbers is going to be the slope? 60. M here is 60 miles per hour. Terrence, please sit up and write this stuff down, babe. Sit up. Okay. Let's look at the equation. Of course, the D represents the total, and since we're talking about distance here, then we assume that we're talking about distance here. So this is the total distance is equal to 50t. T is the time. So it's again the total distance per time or per hour, because it's per hour here. Okay, and then plus the starting amount is 55. Which one of these numbers is going to be the slope? 50 or 55? 50. The number, remember, it's written in slope intercept form. The number that's attached to the x or the domain, which happens to be t here instead of x, is going to be the slope. So 50 is your slope. Which one of these vehicles is going the fastest? Car one or car two?
Car 1.
Car one. The first car is going the fastest because that slope is greater. Okay, so we're going to circle this scenario. This is going faster. much faster is the first car going?
10.
By 10. 10 miles per hour. Okay. Please make sure you're right. Come on, Terrence. You're not doing anything, baby. What's wrong? Okay. All right. Raise your hand if you're still writing. Anybody still writing? Okay. Let's look at the second example. I'm going to draw a line here so I can make sure I use my space better. Let's look at the second example. We want to figure out which has a greater slope. Okay, so let's look at the slope. In order to find the slope of the line, pick 2 points on the line and count rise over run. So I'm going to choose the 2 points in this example. I'm going to choose this point right here. And I'm going to choose this point right here. These are 2 really good points. And now I'm going to count rise.
I don't know what you mean by.
That's okay. I don't know why she always responds when I'm not talking to her, but when I got something I really need to ask, she don't say nothing. All right, rise over run. So we're going to go up and over, okay? So from this point to this point, we go up how many?
Up 1.
Up 1. Very good, babe.
Over 3.
And over 1, 2, 3. Good job. So positive 1 and positive 3. So it's 1/3 for the slope of the graph. So now let's do the slope for the equation. The table. What 2 points are going to be the easiest 2 points you feel?
3 and 8.
3 and 8 is not a point on there.
Oh. Sorry, I thought you could just choose.
They're side by side.
3 and 12.
3 and 12 is an ordered pair. You see how they have to be when X is 3, Y is 12. Input is 3, the output is 12. They're married, okay? They go together. So what's the other married couple? 15. Why are we choosing big numbers? The 15 and 4, but that's a big number, right? So let's choose 8, 9 and 8, okay? Let's choose smaller numbers. Y'all know y'all don't like to count. Shh, you don't like to count. Let me ask you that question. You'll be mad at me. All right, so let's label X1, Y1, X2, Y2. So now let's use the formula Y2 minus Y1 over X2 minus X1. I'm going to use this space for the explanation. So on the top, what do I get? What minus what goes on the top? Come on. What are we subtracting, Tegan?
8 minus
8. Somebody said 8 minus what, baby? You said it. Somebody said it. I don't know. 8 minus what? 12. Thank you. And then what do we get on the bottom?
9 minus 3.
9 minus 3. Thanks. Okay, so on the top, what does that give me on the top? Speak up. -4. Good. And what does that give you on the bottom? 6. All right. How do you reduce that? You divide both the top and bottom by what number? 2. So the reduced fraction is going to be a negative what over what? Negative 2 over 3. Okay. So now, which one of these has the greater slope? Which one has the greater slope? No, that's the greatest number. But remember, when you're comparing slopes, you ignore the negative and positive. This is going up 1 and then over 3. This is going down 2 and over 3. This one is faster than this one, even though this is going up and this one's going down. So the table has the greater rate of change. Even though it's going down faster than this one is going up. Okay? The table has the greater rate of change. Any questions? All right, see if you can do this bottom one on your own. You're going to count rise over run here. And what two ordered pairs do we want to use? 0, 4, okay, and 1, 7. Let's use this to find the rate of change for the table. I'm going to pause for the calls to give us a chance to solve this and to figure out which one has the greater uh, rate. Well, this one says which one has the greater initial value. Let's do both. Let's do slope and then let's do the y-intercept, okay? Let's do slope first and figure out which one has the greater slope, and then let's figure out which one has the greatest starting amount. Pause for the calls. Okay, so let's do it, Ms. Reyes. Let's figure out what it is. Rise over run. We got this point right here. And what is it going up by? It's going up by threes. Because this is 6, 9, 12, 15. So it's going up by threes. So, and then I'm going to choose this right here. This good point. So it's going up. 1, 2, 3. What's 4 times 3? So this is positive 12 on the top. And then it's going up by ones here on the X. So that's 1, 2, 3. 3 on the bottom. So what is 12 divided by 3? 4. So M here is equal to 4. Okay, so this is 4. So let's figure out what this one is. X1, Y1, this is 0, this is 4. X2, Y2, this is 1, and this is 7. So we're using the slope formula, Y2 minus Y1 over X2 minus X1. All right, so what are we going to put on the top?
7 minus 4.
Very good, baby. 7 minus 4. And then what are we putting on the bottom?
1 minus 0.
1 minus 0. So this is 7 minus 4. What's 7 minus 4?
3.
That's 3 over
1.
which is just 3, right? So which one of these slopes is bigger, 4 or 3? 4. So the slope of the graph is bigger. Yes, baby. Yeah, I'm just looking at what you wrote, not if it's right or not, because I hadn't done it. The slope of graph is greater. No, this is the correct answer. How did you get 3? What is your rise over your run?
4 over 3.
How'd you get 4? Tell me.
Because of the point I used at the top, it's near the arrow.
Did you go up by 3s or did you go up by 1?
I went up by 1.
Yeah, because it goes up by 3. Look at you see how the y-axis is going up by 3 each. So every time you go up to this line, it's actually going up by 3s. That's why, okay? All right, so now let's look at the y-intercept. What's the starting amount of this graph? Where does it start when x is equal to 0 on the y-axis? What number is this? What number is this number on the y-axis? What number is this? If you want me to erase it, what number was that? That was 3. So the y-intercept here is 3. B is 3 here. Let's look at the table. What's the y-intercept? What's the starting distance at the table? What's the starting distance on the table? 4. Wherever x is equal to 0, the y value is your b. So b here is 4. Which one has the greater starting amount? Is it the table does? The table has the greater starting amount. The table has the greater y-intercept. Please make sure that you write. I'm going to pause for the calls there. All right. Okay, let's look at the example that's over here. Okay. I want you to try this on your own. I want you to pick whether it's the graph of the table that has the greater rate of change. Let's do that now. Which one of these have the greater rate of change? I'm going to pause for the calls. All right. Okay, so rate of change for the table. Sorry for the graph, Miss Ray. Is the graph. Do the graph first. Pick 2 points. This is a good point down here, and this is a good point here. Okay? So we already know it's a negative slope because the line is going down from left to right. So I'm going to count from here to here. It goes down 1, 2, 3, 4, 5. So -5 over +1. So m is equal to -5 over 1, which is a -5 for the slope. Okay? It's going down 5. Okay. All right, let's look at the rate of change for the table. Make sure I'm recording, y'all. I am. Okay. The rate of change for the table, we picked 2 points from the table. I'm going to pick the first 2 points. It doesn't matter which point you decided to use. If you did the math right, the answer is going to be right. You could have chose 2 different points, but you should still get the same slope because you're going to reduce your fraction. So this is x1, y1. This is x2, y2. The formula is y2 minus y1 over x2 minus x1. Please make sure you study the formula because our test on Friday, you can't use any notes. Okay, so please make sure that you study the formula, you know the formula by heart. All right, so on the top, what are we getting? What minus what? 8 minus 4. What are we going to get on the bottom? 2 minus 1. So on the top, what does that give us? That gives us 4 on the top. What do we get on the bottom? 1. So our slope here is 4. That means we're going, it's +4. M is equal to 4. So that means we're going up 4. Which one of these slopes is going to be greater? The graph is going to be greater because even though it's negative, it's going down faster than the other one is going up. So the graph has a greater slope. Any questions? It's moving the fastest. Even though it's moving down, it's still moving faster than the table. Any questions about that? All right, the last 2 I want you to do on your own and then put your calculator back. This is going to go on what page in your notebook? This is going to go on page 8. So I need you to complete the last 2. Let's do that now and then paste this in your notebook. You do have time, so let's do the last one, please. It's going to be page 8 in our notebook. Comparing functions, page 8 in our notebook. Please make sure you paste down the blank side so that we can see our notes. Paste that down, please. Guys, if you're missing pages in your notebook, please go on Canvas and copy the pages from Canvas, please. All right, let's put our calculators back.